How's it going, everyone? It's Isaac from Chef Games here with our fourth video in our series on creating an FPS weapon system. Today, we are looking at creating projectile weapons. If you're not following this tutorial series and you're interested in creating an FPS game in the Godot Game Engine, I highly recommend checking out the other videos in this series. But if not, stick around anyway, as I'm sure you can still follow this tutorial and learn how to create projectile weapons. A projectile weapon is exactly what you think it is. We're going to fire a physically based projectile out of our weapon at our target, and if it hits, we're going to deal damage. Our game already has been set up to get the collision point from the center of the camera, so all we need to do now is launch a projectile from our gun in that direction. So let's get started. Okay, so now we've set up our camera collision. We've got our hit scan done. Let's come in and set up the projectile. We just need to create a function. But first, let's jump into the weapon resource and create some variables, because if we're doing a projectile, we need to spawn something. So I'm just going to move this export flag down. And below this, we're going to create a new variable at export var, and we're just going to call it projectile to load. And that's going to be a packed scene. So this will be the scene that we instantiate when we create a projectile weapon. Next, we're going to create the projectile velocity. This will be how fast the projectile goes. If you're creating perhaps a rocket launcher, you want it to go a little slower, but if it's a bullet, maybe it needs to go a little quicker. Okay, now I'm gonna choose one of my weapons. I'm feeling Blaster N. I'll come in with Blaster N and I'll change it to a projectile. So make sure at least one of your weapons is marked as projectile. So now we've got hit scan on our assault rifle, but on our other weapon, there's nothing happening. So let's come in and set that up. Let's create first a projectile velocity. I'll just choose 100 to begin with. And we need to create a projectile. So I'm going to use one of Kenny's foam bullets, probably this one here, foam bullet A. So I'm going to create a new scene and I'm going to click other node, and I'm going to grab a rigid body 3D and I'm going to rename it to bullet. And I'm going to drag that model in and make local, and then just get rid of all the other nodes and keep the mesh. I'll need to reset the transform on that, so I'll just do that quickly. And I'll just rotate it so that it's horizontal on the Z axis. That's pretty important for a bullet. I'll save that scene under our tutorial folder. Now I'm just going to bring in the gun model just so I can see, how this is going to look in comparison, if I need to make any changes to it. And I think I am going to make it a little bit bigger so we can look. It is the right size, but I think it could be bigger. So I'm going to make it a little bit bigger. I'm going to delete that gun and reset the transforms. Now I'm going to play around with the material. You guys don't need to do this, but I think because it's a laser, it's going to be emissive. And so I'm just going to set up an emission, make it super bright, just because it looks cool. Nothing really, no other reason. Okay, you can choose multiply, but it doesn't really look that good. So add is what you want to keep for the operator. And we need to create a rigid body. Now I'm going to create a capsule shape, and I'm just gonna obviously rotate it, and we're gonna need to make it substantially smaller. The trick with rigid bodies, turn off snapping here, is that you want them to be a little bit bigger than the projectile that you're actually shooting, because I don't really know with Godot 4 if the physics is worse. In Godot 3.5, you couldn't really use projectile weapons for like fast shooting weapons. You could really only use them for like rocket launchers and things like that, because the physics engine could not detect the collisions 100% of the time, and you had to do a lot of like trickery to get it to work. But at least in my testing with Godot 4, it seems to be significantly more reliable with the new physics engine. So I'm going to go ahead and set this up, and you shouldn't really have any issues, but if you are having problems, it could just be engine related. Just keep that in mind, I guess. I'm going to select continuous CD on the rigid body, and I'm going to set the number of contacts to 10 and select contact monitor. This will allow it to detect collisions. I'm going to reduce the mass to 0.1, and I'm going to create a script. Okay, so the first variable is obviously the damage. We're just going to set that up as an integer, and it's going to be 0, but we'll work on that. I'll explain that in a second. And we'll connect the signal up, body entered, to this script. And we'll go if body dot is in group, brackets target. This is a group we set up in our previous tutorial on hit scans. And the body has method brackets hit successful. So those two things are required here. So if you don't have a group, set it up now, and you'll need a method on the thing you're trying to shoot called hit successful. And we'll call that function if both of those are true, and we'll pass in the damage. And we'll queue free, and then we're gonna queue free regardless. You could just put that on the outside of the if statement as well. I'll also create a timer just in case we don't hit anything and this goes flying off into nowhere. We'll just delete it after a certain amount of time. Okay, that should be all we need. We can close up these folders, make things a bit neater. We can jump back over into our blaster resource, and we're going to drag that projectile to load into that resource there so that we have that on file. We can come back over to the weapons manager now, and we can start setting up our projectile method. So we've got our camera collision. This is an important function. If you don't have this, you definitely need it. We are going to be returning the collision point or the end of the ray. So we're going to always have a place to send our projectile. So that's why we need to return the ray end, just in case you shoot into nowhere. So under projectile, I'm going to create a function called launch projectile, and I'll pass in the camera collision. I'll create this function down here, function launch projectile, and it will take a variable called point. The first variable that we need is the direction, and that is going to be the point minus the bullet point and get global transform dot origin. And we're going to normalize it. This will be pretty familiar if you've done the hit scan. Next, we're going to need to instantiate the projectile. So I'll create a variable called projectile, and I'll say current weapon dot projectile to load dot instantiate. And I've just realized that I've made a spelling error, so I'll come up and fix that. Next, we are going to need to instantiate this bullet. So just make sure that the bullet is set as top level for this, because we're going to instantiate it under the bullet point, which is a part of the kinematic body. So under bullet point dot add child, we're going to add the projectile, and the projectile dot damage we will set to current weapon dot damage. And then projectile set linear velocity, and that'll be the direction multiplied by the current weapon dot projectile velocity. So just make sure that the bullet is set as top level for this. So that's super important. We also need to set up the collisions, layers. I haven't explained these yet, but one thing I've noticed is that with Godot 4, the physics bodies do need to be on a separate layer. So they weren't working for me when I originally set this scene up. And so now I've created a physics layer called objects on layer 3. And layer 4 is the weapons. So make sure you set your projectile to have the same collision layers as well. We're going to put it on the third layer, and we're going to have it mask layer 3 and layer 1. So it's going to interact with anything on the world layer. And keep in mind with your enemies, if they are on a separate physics layer, to make sure to select that mask here for your projectile. So here's the box. It is on layer 3 and it's masking 1, 2, and 3. So it can interact with anything on those 3 layers. Let's run the game here. We'll swap over to the weapon that is a projectile, and you can see it is spawning those projectiles and shooting them. And then we'll shoot the box, and you can see it rolled. It's definitely hitting it, and you can see below in the console that the target health is being reduced. So that is working how we've expected it to, which is really amazing. It is just that easy. Okay guys, it's Isaac from the future here to interrupt this projectile tutorial. I found a slight bug in the code. I don't know if anyone would have picked up on it or even noticed, to be honest, because it's just something that can happen, but might not, depending on how you've set things up. So you won't see it actually in the video, but I did notice it when I was playing around with like a big projectile that you're shooting and you're shooting it rapidly. Something that happens, I'll play this here. I've made a couple of changes to this project. It's been a long time since I recorded that original, but here's the gun and this is a projectile. So it's quite a bit bigger and this has been changed to automatic. So if I hold this down, watch what happens. Look at these last two. They start going off in a completely different direction. Now you might wonder why, maybe you've already worked it out, but it is basically the raycast from the center of the camera interacting with the actual projectile rather than going through that and hitting the thing behind it. So that will change the trajectory of the projectile because the direction that we send it will be just based on that reduced distance, right? So the bullet is much closer to the player than the wall is over there. And so it's just going to go in a completely different direction and it won't line up with the reticule in the center of the screen. So it's going to be pretty noticeable. You can tell it veers off like that, which is pretty weird. So I'm going to quickly show you guys how to fix that. I'll jump back over into the project. Things are going to look a little bit different, but you'll just have to bear with me. We have got our camera collision, and then we've also got our launch projectile. So the flow of the code is essentially, if I come back up to shoot, you can see that I'm getting the camera collision, which is we're shooting a raycast from the camera to wherever. If it's hitting a wall, it's coming back. If it's not hitting anything, it's just coming back with the farthest point away. And then we're passing that to the launch projectile and we're throwing that from the bullet points. That's like the muzzle of the gun is where that projectile comes out and it goes towards that end point wherever it's collided with. And generally that's meant to be at where the center of the camera is. So that's why it hits that reticule. But obviously if it's hitting the bullet, that's like not where we want it to go. And so it's not going to line up and it's going to look weird. So what we need to do is we need to add an exclusion to this physics ray query parameter 3D. And it's got a exclude. And we can set exclude and we can pass a value. It takes an RID. So we need two things, right? We need to get the RID from the bullet, which is not that complicated. What we can do is we can set up an array. I'll do it underneath this enumerator here. So I'll go var collision underscore exclusion, and I'll set this equal to just like a blank array. No, that's not the one I want. There we go. And I'll come back down to the launch projectile, and what I will do is after we've added the child, actually after we've instantiated really, we can do it. We can get the projectile, we'll create a variable called var projectile underscore RID, which will be equal to projectile dot get RID. This is just a built-in function for any collision object. And then we will just go collision exclusion dot push front, doesn't really matter, projectile RID. I actually think pushback is faster. We're not going to store that many. So now that we've got that being added to an array, what we can do is we can come back up to the physics ray query parameter 3D, and right after we create it, we can just write new intersection dot set exclude. I think that was set exclude, and it takes an array, and we'll pass in that collision exclusion. And now that won't happen anymore. So let's run the game. Switch to our gun, and you can see that it's going straight ahead perfectly anytime. But now we've got a new problem. The new problem is we're creating an array of RIDs and it's ever growing. And I've stress tested this, and you can get to about 5,000 before the game will crash. So we need to remove these as they are removed from the scene. So we need to, right after we have created the projectile and we've added it to this exclusion array, we need to also hook up the tree exited signal of the bullet to the weapon manager. This is the bullet node, and under signals we've got tree exited. So this is emitted after the node exits the tree and is no longer active. Okay, so like I said, we need to hook up that tree exited signal. So we'll also need to set a func, and we'll go remove underscore exclusion, and this will take a projectile underscore RID. And then all we'll do for this, I'll write this code now. We'll go collision exclusion dot erase, and then we'll pass in that projectile RID. And I'll also spell that right. Put an E on the end. Oh, 3 like a badass. Okay. And just set that up like that. So that's all we need for the exclusion. Now we just need to link that up with a signal. Now, signals have changed a lot in Godot 4. And one thing I was learning as I was doing this is that you can just call directly a signal. So it needs to look like this. So we can go projectile dot tree underscore exited dot connect, and then brackets, and then it just needs to be remove exclusion dot bind. And then in this, I can pass the projectile RID, but I think it should be projectile dot get RID. So you can see off to the right here, I'm creating that, and you can see it grows as I move further back. It's kind of hard. I wonder if I just like send these out. This is probably the best way to do it, because they expire after 10 seconds and they'll just delete themselves. So you can see it grow up to 21, and as they delete themselves, they should get reduced, and you can see them going down like so. And so that, in my opinion, is the best way to solve this issue that I showed you before, where it's not going directly to the center. What we need to do, just to recap, is to get the projectiles RID and add that to an exclusion list for our physics ray query parameter up here in the camera collision. You add that to the exclusion of that, and it won't actually, the raycast from that won't detect the bullets, which is exactly what we want. But also we need to remove those from that array as time goes on, because an array can only get so big before the game crashes, as I've discovered. Might be obvious to some people, I don't know, it surprised me. And yeah, so you just, you hook up the signal like this, projectile.treeexited.connect, remove exclusion.bind, projectile.get RID. It messes with the head a bit, this new signal thing, but anyway, that's how you do it. Okay guys, that's all there is to it. I hope you found this tutorial helpful. I really do appreciate a like and subscribe. Hit the bell if you want to keep an eye out for the next episode in this series, where we're going to add physics to our hit scan weapons so that they're sort of the same behavior as our projectile weapons. If you don't want to wait, you can always subscribe to my Patreon at patreon.com/shaftgames, where you can get my videos in advance. But that's all for this week. I'm Isaac from Shaft Games, and I'll see you next time.